Hello, I wanted to put together this very short video to try and help explain how you change the subject of something or rearrange an equation. I've just got three examples that we'll work through, and they get slightly harder with each one. So if we start with the first one, our goal basically when we're rearranging is to move everything apart from the x from one side. So we'll keep the x over here since this is where it starts at the minute. It was explained to me, and I think this is potentially the easiest way to explain it, though you wouldn't need to draw the scales yourself when you're working it out. Is at the minute I've got a y in here, I've got a 2x or 2 times x plus 3. If you have a number and a letter like that in isolation, it means they're multiplying by each other. So that means 2 times x. So what we want to do is take everything out of this side apart from 1x and move it into that side. But we need to keep the scales balanced. So what I'm going to do is I'm going to start by taking out this plus 3. So that it leaves me with just 2x on this side. But because I've taken it out of here, that's made this side heavier. So I need to take a plus 3 from that side as well. So if I'm taking it out, I'm going to take, okay, hopefully that makes sense. So that's now left me with y minus 3 equals 2x, which is fine, but I've still got 2x's on this side and I only need 1. So what I need to do now is divide this side by 2, because that will eliminate the times by 2. So that will leave me with just the x on this side. But once again, I've made the other side heavier. So in order to keep them balanced, because I've divided this side by 2, I need to divide this side by 2 as well. So that will leave me y minus 3 divided by 2. And by writing it like that, it means that everything on that side is divided by 2. Whereas if I just write y minus 3 divided by 2, what I'm actually doing is just 3 divided by 2 and then y minus the 3 divided by 2, which would be wrong. So make sure you have it as y minus 3 divided by 2. Okay, I hope that makes sense for the first one. Okay, so for this one, what we need to do is just have the R on one side. We need to remove everything else. It looks slightly trickier, but to be honest, it's not much trickier than the first one was. So once again, we've got A equals pi times the radius squared, which is the area of a circle. Okay, so the first thing we need to do is, what I suggest is take this away first, because what we're doing is we've got pi times the radius squared. The radius squared is one thing. So we want to take away the thing that is further from that. So that's pi. Okay, so what we want to do is rearrange this so that we've just got the radius left on this side and everything else has been transferred to the other side. Because we've got pi times the radius squared is basically said as one piece. And so we will get rid of the pi first, because this is separate to radius squared, okay? So what we'll do is, at the minute, we've got pi times the radius squared. So like in the last one, to get rid of the times, we'll divide. So that means we'll have the area divided by pi will leave us with the radius squared. So far what we've done is we've divided both sides by pi. Okay. That's fine, but our radius is still squared and we don't want the radius to be squared. We're trying to work out what just the radius is. So what we need to do now, to counteract a square, we square root it, okay? So that means what we'll have is the square root of the area divided by pi. You might be asked a question like that in your Maths GCSE question. What they might do is say, a circle has an area of 53 centimeters squared, work out the radius. And then what you would do is you'd substitute in the 53 for the A, then you'd divide it by pi, you'd square root what you're left with, and that would leave you with the radius. So that's when things like this may also come into play. It may not just be a case of rearranging it. It may actually be a case of rearranging it and then actually using that information to solve something else. Okay, so finally what we need to do, this one looks complicated, but to be honest, I don't think it is going to be any more complicated than the others are. Okay, what we need to do is make t the subject this time. So we want everything moved to this side apart from the t. Okay, so what I suggest we do is get rid of the plus ut first. And the easiest way to do that will be to take them away because we're taking them out of the scales. So if we're taking them out, we'll subtract them. So we've now got s minus ut equals a half of at squared. Next, I would suggest we try and remove this half. And so in order to do that, what we need to do is multiply both sides by 2. So that will give us 2 brackets s minus ut close brackets equals at squared. So by doing that, everything on the left-hand side is now being multiplied by 2. The next thing we need to do is get rid of the a because that's the least attached to the, it's a bit like playing pass the parcel, and we'll get rid of this layer before we can get rid of the next layer, then we'll get rid of that layer, then we'll get rid of that layer, and then eventually we're left with the t in the middle. So we're doing a similar sort of thing here. So what we're going to do now is get rid of the a layer. So now is a times t squared. So in order, once again, to get rid of a times, we need to divide. So that gives us 2 s minus ut divided by a equals t squared. Okay, and I haven't left myself enough room here. Okay, so now we're once again left with something squared. So in order to get rid of a square, what we need to do is square root it. So, but that will leave us with 2 s minus ut divided by a. Everything is square rooted so that it's left with just a t on the other side. And that would be your final answer. I hope that made sense. Any questions, as always, please do ask. And thank you for watching to the end.